So here, when we talk about abstraction, right, take an example of real-time things. What we normally do, we normally say, let's create an abstract prototype and then let's build the project or let's build something, right? So which means abstract is like an idea which is not associated with the specific instance, right? Like take an example of a building, right? So whenever we are building a house, so what do? We normally create a prototype first, right? And then we normally follow the prototype with all the dimensions, whatever we have concluded, and then we build a house, right? So the prototype which we have actually plotted on a paper is called an abstract prototype for building a house, right? Same way here, we can also create abstract classes where you can actually restrict users to do some functions. Like let's say in your abstract housing model, right? You said your wall should be some 100 feet height. Now what does it mean? While building, you're restricting builder to make a wall 100 feet tall, and that's it. You can't actually go beyond or we can't restrict from there, or builder should build a wall. That's very important again. Should build a wall, and whatever functionality is being provided should be obeyed. So that is something which is an abstract in real-time design. Same way here, abstraction is a class where you can create few abstract methods or functions which can define the classes, like how they actually should function. We'll actually take up an example anyways. And one more very important property about abstract classes are you can't instantiate your abstract class, or you can't create an object of your abstract class. If you create any class, you can create an object, right? We all know that whenever you create a class here, right? Let's say you have a class called parent, right? You can directly go and create the parent object, like obj something, right? Now this is called as a instantiating your class, or actually creating an object of a class. Now here we said we can't instantiate a abstract class because it's just a prototype, right? So let's see how we can actually write a simple abstract class, and then we'll see more properties of abstract class, how we can actually use, and what are the internal things which we can use in abstract. Fine. Now let me create a new class, I guess. So to take an example, let's create something called vehicle. Let's take vehicle is an abstract class, right? Where I'm going to actually provide some functionality in vehicle class so that whomsoever uses this vehicle class, right, may have to follow them, right? So let me create a vehicle abstract class. Let me create a class first. Let me call it as vehicle. So in order to make a class abstract, right, so we have to use a keyword called abstract. You can see. So whenever you use a keyword called abstract or a reserved word called abstract to any class, then the class becomes abstract. Right? Now this is an abstract class which you have. Let me create a main some other class over here. Let me call it as class trigger again. Trigger. Right, so this is something which is a main class. That's it. I'm just taking the call and string. Okay. Now here you have abstract class. So here in abstract class you can have both abstract and non-abstract methods. What is the difference between abstract and non-abstract methods? Now, till now, whatever methods we have created, like print data, get data, and all, right, they are called as a non-abstract methods. So the main difference between abstract methods and non-abstract methods is You can have body for abstract, for non-abstract methods. If you go back to our previous classes for that, let's take this parent. You can see one simple method called public void print data, where this is called as a body of print data. And normally whatever we define here, return type and the parameter side, they are called signature of the method. This is called as a non-abstract method issue. But whereas in abstract method, you will not have the body, but you have just a signature of your method. That's it. Now let me show you one abstract method. So in order to make abstract, we have to use again a keyword called abstract. Let's say void. Let me take method called start. See the method here. Now this is how we define the method. This is a method. When we define any method abstract, right, then we have to make a complete class abstract. Very important concept, right? So let's say if a complete class is non-abstract, usually, right? What I do, let's say everything is fine. Now this is something which is a non-abstract class, right? Everything is fine. Now let's say you want to make this start abstract. Why? I want to make this start abstract because I'm creating a vehicle class. Let's say this vehicle class is you implemented or inherited by let's say a car or a cycle, let's say, right? Both are vehicles. But you can see the starting, the way how you start car is not the same way how you start a cycle, right? Which means in vehicle I can't actually define what to do in start. That's the reason why what I'll do, I'll just make it abstract. But where will I define how to run a car and how to run a cycle? That I'll define whenever I'm using this. See here, when I declare a class and I declare a simple abstract method, I label this, right? Now see what happens. Here it says, you can have abstract method only in an abstract class, or it's a vice versa. Here it says in a non-abstract class you can't have an abstract method. So that's the reason why if at least one of your method gets abstract, then you have to make your complete class abstract. Then it is fine. Now rebuild it. I can see. Fine. So do we have entry points or other? Yes, let's remove those entry points. That's why I'm just removing entry points so that I can use my vehicle class directly. Fine, perfect. Now in this way, I can have any number of abstract methods. I can say abstract void of stop. How to stop, I don't know. But I'm just forcing user to use my stop. Now, as I said, I can also have some non-abstract methods, as let's say get model, which model it is. So in this, let's say I'm gonna print console.write line of some, let's say 2014 model. Right? So here, this is my syntax of the abstract class, where I can have both abstract methods and non-abstract methods. You can have combination. Right? So here, check out whether I am able to create an object of a vehicle or not. When I try vehicle, right? So here what I'm doing, I'm trying to instantiate my abstract class. Now you can see, you cannot create an instance of abstract class or interface. Anyways, we'll come back to interface again. Now which means, now you would have understood why it doesn't allow us to create abstract class object, because it contains some signatures or some methods which doesn't have any functionality written, right? Then obviously there is no meaning in creating an object of vehicle. That's what is a behavior of abstract class. Now this is about abstract class, how we create. Now what is the use and how can I use this in my classes, let's say, right? Let's say I'm going to create one more class called car. This is my class. Now, while building a car, right, what I want to do, I want to ensure what are all the different functionalities which are mandatory, let's say, right? For a vehicle, let's say whenever I'm creating vehicle class, I don't know what are the mandatory things I have to write for. So in that way, what we'll do, I'll just use this vehicle. Now, how can I use abstract class in some other class? It is again by using the resolution operator, which is how we have used our inheritance. Now again, what I'm doing, I'm inheriting my abstract class into my car class. Right? Now these are any inheritance. Probably what I can do, rebuild this, see what happens. Now when you rebuild this, right, see, as soon as you inherit an abstract class, see here what happens. It says car does not implement inherited abstract member called start. See, my abstract class forces the class wherever it is inherited to use to actually write overridden methods for start and stop. Right? Then what I'm going to do, I'm going to write override. See, I have a shortcut here. If you type in override, right, and click on start, you'll actually see start. Or else, if you want to write, you can also write your own way. Override, void, start. Right? Now, here I've overridden one abstract method. Then again, I have to override my stop method. Right? Now what I've done, I've actually overridden both the methods. Let me rebuild. Now you can see there are no errors. Right? Now whatever methods I have in abstract class, which are abstract methods, all the methods it's mandatory to implement in a child class. Write one more method like public, abstract, void, let's say, move forward or backward, right? Now rebuild this, see what happens. Again, it will give you an error. So in this way, unless you override your move method, right, it won't allow you to create a child class. Now in this way, if you can see what is happening, you can actually see this vehicle abstract class can be used by many other classes. Let's say some 20 classes are using this vehicle class. Tomorrow what I'll do, if I have to implement one common functionality across all the classes, what I do, I'll just write or just insert one more abstract method. Then what happens? Then automatically everyone who actually have created the classes which are used in this abstract class, they have to provide some functionality for this. Right? That's how it happens. Now here you can see, now I can create my functionality. Let's say here I'm going to write how to start a car. Let's say it's a key based, right? Or auto start something, right? Right. Now here you can say again key based stop, right? So move here, right? Something called, let's say forward. I'm just taking examples. Okay? So now we have a complete functionality of it. Now apart from overriding this, you can also have your own customized way of class. Let's say I'm going to take my own methods called field type. Let's say I'm just taking something. Right? I'm just taking console dot right line I'm just writing and something that, yes. Now this field type is more specific to the car. And now if you create an object of car, object car, right? Now you can see, you can actually access everything. Stop, start, move, right? Let's call everything. We have a start method, we have a stop method, right? We have move, and let's say we have one more method called return method, which is get model, right? I can use the abstract class non-abstract method, I can also use that. Now you can see I'm using it, right? Now here let me call it console key so that it can start method. Now you can see it says key based, stop, key forward direction, and so on, so model. Now you can see that I'm able to create my class, child class, and I'm able to restrict that to use all the functionalities. Right? Same way, if you have one more, see what happens. If you have one more type of vehicle called, let me say, bike, right? So here, let's say I'm gonna use vehicle abstract class to inherit. Now again, if I build this, again it will give you error that you are not using, you are not overriding all these three methods. So let's override them. Override start. So here by default it will actually give you throw new. We'll learn what is throw. It is something which is an exception handling related. So we have override, you can see stop here, and override here. Fine. Now it will accept. So here I'm going to create my data console.println. Let me just say key paste. Let's say switch paste. Stop. Right? Just say, let's say this is also forward. Right? Now you can see even my bike has got different methods, but what happened? But for bike, all these properties are same. Start, stop, move. I mean the features are same, but the working model is different. Right? So here you can see when I create a bike object, it will actually exclusively take those functions. You can say obj bike dot, we have a start method, obj bike dot, we have a stop method, let's say, move, and you can also have a model, right? Because get model is common. Let's say whoever is using this vehicle abstract class, I'm saying they are all 2014 models. Whoever uses, I mean, if I create one more method and say get color, right? When I create this abstract class vehicle color as blue or any other color, right? Then all the objects are like whatever I'm using, it gets a color of the same thing, which means you can have a whole at one single class. Now this is something which is called as an abstract behavior of a class, right? And how we can actually use. Now one step ahead. Now let's say I'm creating one more class called, let's say I'm taking an example of Benz, which is more specific to the car type, and I'm going to inherit car. Let's see what happens. If I rebuild this, right? Now see what happens whenever I inherit car, right? Which means car is a normal class, and I'm inheriting the car to specific type called Benz, which means whatever functionalities are written in car, start, stop, move, however car moves and all, it gets related to Benz. Now you can see that by creating abstract class, we are actually building the functionality, what to do. And by inheriting this abstract class, we are actually writing how the functionality should work, right, as a general. And by inheriting this car class into the specific object, right, or specific object class, we are actually implementing them. So here, Benz, I can create an object of Benz and I can directly use start, stop, and move. Right? So this is what we call as an abstraction or abstract way of operation. So normally, you should have at least, you can have abstract class without anything. You can have all methods abstract. So whenever all methods of abstract class are abstract methods, then we normally call it as a pure abstract class. Right? So that's the reason why we normally don't call abstract method as a normal abstract method. We normally call it as an operation. So your abstract methods are normally called as an operation in an abstract class. Okay. So this is about abstraction which we have, right? And abstract methods and different things which we have. Now again, this is a class which you have made as a template. Here you can have. So any questions till now? Now let's go to the next one, which is an interface. Now, why I actually considered abstraction and interface side by side and not a separate one? Because the working model of abstraction and interface matches a bit, right? Now, normally, whatever we have seen till now are classes, right? But now whatever we are going to see is an interface. Interface is like quite different from class. We have used class for encapsulation, we have used class for polymorphism, we have also used class which we have used for abstraction, right? But here interface is separate entity as such in .NET. Not in .NET, in OOPS. Whatsoever platform supports object-orientedness, right? You can create interfaces in that. Now, the actual model or actual abstraction way is provided by, the actual abstraction model is actually being provided by interface. Let's see what is the difference mainly. So the main difference is we can have only operations or just signatures in interface. We can't have a method with body. We should not call it as a non-abstract method, right? We should not call it as, but here in interface you can have only methods just with signature and nothing else. Let me create one simple interface. Maybe I can create a new class and we'll make it as interface. So here let me call it as sun interface. Right? So let me take it as a figure class. So now static void main string. So let me create a simple interface. So for interface we will be using keyword called interface. Now again, we are not using this keyword as a prefix of interface. Don't get confused with the class interface. We use abstract keyword in order to make a class abstract class. But as I said, interfaces are different from classes, which means you can create an interface as a separate entity. Let me create interface as vehicle itself. So this is a simple interface. Right? Now here you should not create any method with definitions. Right? Only with signatures. Let's say I have void start. That's it. Nothing to make it as abstract or any other thing. So void start. You can't have void, let's say, get model and this. No, this is not allowed. When you run this, you can see the namespace oops already contains a definition vehicle. Okay. This is some other error. This is let me call it a vehicle 1. Right? My interface because I've already created vehicle class in here, right? So that's the reason why it won't allow me to create in the same namespace. It won't allow me to create same. Firstly, it won't allow two different classes in the same name, right? Either at least it should be a partial class, right? Not complete class. And second thing, your class interface cannot have a same. That's fine. Now here you can see that its interface members cannot have a definition, which means this will not be allowed. Only you can have a simple interface. That's it. Now you can have usage. That's the reason why we actually started with abstract, so that you can understand interface in much better way, right? Now here I can have a class, let's say again a car, or this time let me take an example of bus. Right? Now how can I use? I can again use a resolution operator, to actually call a vehicle norm. Now here, this time you should not call it as an inheriting vehicle, but you should always pronounce this as I am implementing vehicle. Your interfaces can be implemented and your abstract classes or normal classes can be inherited. But the way how you use this say, we use a resolution operator to actually implement or inherit your data, inherit your classes. But here, interfaces can be only implemented. Fine. Let's rebuild this. You can see again it will give you that you have to implement your methods. Now you see here, I'm not saying you have to override your method. No, that is not correct. Now if you are actually using interface, you should implement it. That's it. Now here you can see I can have start the substitution. This is called as an implementation of it. Now I can have void stop the same name and the same execution. Now you can see this is an implementation of it. Now you can see the build succeeded. Now this is how we use an interface. Now you can write your start vehicle, how to start and how to stop. Again, if you are using some other class, right? Like let's say class, let's say bike 1, which implements your vehicle 1, let's say, right? Again here we have to again implement your start and stop. Right? So this is how we normally create an interface and use interfaces in this way. Okay. So this is called as your interface in .NET, and these are the complete concepts of OOPS, which is encapsulation we have seen, inheritance we have seen, polymorphism and abstraction interface. Now again, when it comes to abstraction interface, again multi-level single abstraction inheritance or interface implementation is possible. That's it. We can't have multiple interfaces here. I can't use multiple abstract classes here. Right? So this is what we have introduced. So if everything is fine, then let's go to exception handling. Now, why do we need a separate exception handling, right? And here, whatever we are writing, right, code, whenever we write any code, it doesn't mean that everything whatever we are writing is correct. Right? It may occur that you may have some issues in between, right? Whenever you are writing up, right? And each statement, right? Whenever you are actually running up, right, you may get some errors due to some irregular operations, right? So that's the reason why it's very important to handle an error, because the one which you cannot predict, whatever you can predict, yes, you can actually solve it out. So what does it mean? I mean, you can actually predict a few things you can't actually imagine, right? So that's the reason why we have two different types here, which is an error and an exception. Now what is the difference between error and exception? Now theoretically they may be saying that okay, error and exception are same. But here, what is an error is, I am actually talking about the design time error or development time error or the compile, not even compile, it's design time error. What does it mean is, let's say if I do some mistake in here, let's say I just missed it, right? Now you can see it immediately compile my program and it will give me error that okay, whatever you are using doesn't seem to be supported, right? And it will give you error. Now this is an error and you have to clear and you have to fix it up, right? And how to fix it? Now until unless you fix this right, your program will not be compiled, and until unless you don't compile your program, your binaries will not be created, or DLLs will not be created, or libraries will not be created. Until unless you have a library, you can't be able to deploy or give it to someone to use it. That is something which is an error, which our Visual Studio will help us to solve them, right, in some other way, right? Now what is the exception? Now let me create a new project and show you, and let's create a simple exception. Got errors, exceptions. Right? So let me take it as a startup project. Now here, let me create an int array, simple int array, as a is equal to, let me provide some numbers. So here you can see I have numbers 12, 23, 45 and 45, where I have total count of 4 different numbers. Right? Normally what happens when if I want to retrieve any data, how can I do that? I can actually access a variable of array and provide the index of the position for a value you are looking for. Let's say I am looking for third value. What does it mean? If you are looking for third value, which means I am looking for third, which will be at index 2, right? Because the index starts from 0. So now let's right? Now let's run this. Now you can see you get a 45 because this is something which is in your regular way you are doing, right? Now let's say we are actually considering input from user, right? And then we are trying to get the data. Let's say I'm going to use follow here. Let's say for maybe 5 times, right? And what I will do, I'll just get the data. But before getting data, let's say I'm gonna take enter position value right. So here what I'll do, I'll just take it. Line, right? And what I'm going to do, I just convert int, let's say 15 hours, right? Or also you can also use your convert. Fine, anything is fine. Convert to int or right? And I'll use t here. So it means that so whenever I am taking a value, right? So this is nothing predictable. Now let's say I am just taking enter a position value from 0 to, let's say I am just giving you an instructions I am giving that okay, enter a value in between 0 and 3. Right? Let me run this. So it says 0 and 3, okay, I am giving you 2. Okay, and it will give me first value. Let me say I am giving 0. Yeah, that thing is fine. I am giving 3 again. Right, 1 again, 2 again, right? Everything was fine. So anyway, this actually completed my shell here. Let's see. So here, if I have t value as something like, let's say, -1, I'm just taking a simple to play my loop. So here, see what happens, even if -1, 3, whether it comes to this position or not. Let's say I'm going to take 2, everything is fine. Let's me take the value 9 here. Now when I take 9, see what happened. So this is called as an exception. Now when did it happen? It happened when I completed my development, right? And I started running this program, and during running this program, right, user entered a value which is out of my range again. And we know that this array contains only 4 values, but I opted for 9th value. Now that's the reason why you can see it gave me index out of bounds of array, and that's it. Your execution may stop here, which is your unhandled. You can see this exception was unhandled, which means we haven't handled this exception, and it may be a chattel error. right? It may actually close up your execution. Now from here, it won't move to the forward. Now execution stops here, either it's stuck or your complete application will be crashed. This is called as your exception. And here, we know that error we can handle, but exception is something which we have to predict or handle in a generic way that your program should not stop. Now that's the reason why we normally go for exception. Now let us see how to actually do handling of exception. Now we have 3 keywords which you can use called try, catch and find. So these are the 3 keywords which we have to handle exception here. And we have many types of exceptions which we can handle, but for all, one class is a mother class which is our exception class. So this is a mother class of all type of exceptions. Now you can see, as of now we got an exception called index out of range exception. Can you see this? Index out of range of exception is one of the type which we have. Right? In this way you can have many, like null pointer exception, right? Or an object missing exception, right? We have got many. You would have seen whenever we have multiple things defined, right, and it is not able to convert, like typecasting exception, right? So everything you can have. Now let's see the basic type of exception work which we have. So here what I'm going to do here is, so all this code, whatever I've written here, right, I'm going to write it inside my try catch, right? Let's see how to, what is the syntax of try catch? We have your try, which is a keyword, open brace, close bracket, and we write a catch statement which accepts an exception in open bracket and close bracket. Because this is a syntax of your try and catch. Now what exactly it conveys is, whenever you write a try and open and close brace, right? Now this is a position where .NET exception will start tracking for exceptions. If it gets any exception, it will directly get the pointer to catch, and this catch is something where you can actually handle it. That's what happens. Fine. Now let's see how it works. So let me just copy this to the end. See what happened here? What I'm doing here, I'm just trying to get the data. Right? Now let me remove all this program and let me write simply. Let me say I want int I is equal to a of 9. Simple. Or 8, 9. Anything. And after this, let's say I'm going to print console.writeLine of value of 5. So what I wanted to do is, I wanted to actually, let's say I'm taking 2 first, right? When I run this, see what happens. Everything is fine, 45, and when I enter it will go. Let's say I'm giving something more, and see what happens. So here I have, it's waiting, which means we got never action. Where is the pointer here? It's not taking the okay. So it's taking one. So let me put a pointer here. Now you can see, whenever I get an error, I said whenever I try and catch, right? So each and every statement, right, your exception tracking will start. Try in the sense, try to get any exception, try to track any exception if you have, and immediately throw it to key. See what happens here? When I run this, see, you come to my debug. So here I know that my exception will happen. See what happens? It will directly go to catch. Even if you have hundreds of lines of code here, right, it won't execute any of the code, right? That is how exception works. It will directly catch the exception and immediately it will go to execute. Now here, which means at least it is saving our program from cache. So this we are actually checking at the high level of exception. Now here if you go to F10 again, now you can see the exception here. What exactly? We got a index was out of bounds. This is the actual message we have got in this cache. And it will actually wait for real key. Here let me show the exception here. Console.write of exception and the exception is, let's see the exception. We have something called E is an exception type, object of exception. So what happens if any exception happens? It will directly assign the object of exception, and it will directly, it is like a method call, right? So method which will be called immediately if any exception happens. If no exception happens, then your catch will not be triggered. I'll show you that. So in your object of exception type, you will always have few internal methods like message, right, and other stuff. I'll show you other things, what exactly we can actually have, like stack trace. We have many more things in exception handling. I'll show you that. Now let me run this again. Now I got an exception. Click on enter. You can see directly it came. When I run this, now you can see exception occurred. Index was out of bounds of array. Now you have handled your exception and enter again. Now let's see whether if everything is fine. If my program is not throwing error, let's see whether it is catching it or not. Let me run this. You can see everything is fine. Now you can see it will print my value and it will go to close of file, and you can see it will directly come to my data. Now this will never be executed. Now that's the reason why unless you have any exception, right, now your catch will not be executed. If there is an exception, all other steps will be skipped and it will go to catch. Now this is how it works. So this is how we normally handle exceptions in .NET. Now what is finally? Finally is a block which we use normally at the end of try, right, or at the end of catch, right, in order to do certain tasks for sure. Even if you get an exception or not, doesn't matter. Your finally is a block which will be executed for sure. Now how to write that? You have a finally keyword and you have a block. Now this is called as a finally block. Now let me print here like console.write of. This is a finally block. Right? Now let's run this. So initially I don't have any error. I have it 2, right? Let me run this. Now you can see I got a right value and it says finally block executed, right? Now let me create an error. When I run this, you can see an exception happened. Index out of bounds of array, but my finally block executed for sure. Right? If you want to debug, I can show you debug way. Run this. So here I'm getting an exception. It went to exception and it printed exception, and then you can see it goes to finally for sure. Right? And it comes out. And let's remove the exception. Let me run this. Now you can see I don't have any exception. My try open and close completed successfully. Now it will go to directly finally and it will execute like that. This is how try, catch and finally works. Try, catch are mainly for exception handling, actual exception handling. Exception tracking is try is for exception tracking. If any exception happens, it will move the point to catch, and catch is the one where actual exception handling is done. And in both the situations, we have finally where we will be doing a final task. If there is an exception, we'll do something else. Right? So that is how we normally do for try, catch, and move. Now, moving a step ahead. Now here I said, if any exception happens at this point, then all other statements will be skipped, right? Which means if I have some logical closure of things after this, right, then what can I do? Let's say I'm getting I value, and based on some I value, I'm calculating something. Let's say what I'm doing in I or int x is equal to, I'm just doing something called 12 divided by I, right? Or doing some operation, and then these I have two different statements to work on, but I'm not getting chance to work. So here I'm going to print x. So if there is no exception, then everything is fine. But if there is any exception here, then all these two will skip and my program is, my program execution is incomplete, right? So in that situation, if you know that a particular statement or a particular block of statements, if you feel that there can be an exception which can happen, then what you can do is you can create even nested exceptions too. Now what is that? Here, let's say in my try, what I've done, this try catch is something which is try catch for the complete method, let's say. I mean, whatever happens inside a complete block, I'll catch it. But what I can do, I can actually write try catch for a specific statement or specific block of statements also. See how? Now let's say here I have, I'm just taking 0, 20 and all. Now I know that an exception may happen here, let's say, where I and so on. So now here I can create my try catch. Now again the shortcut, you can go with the control KS and try to try. Now you can see the complete try catch will be there. Now this statement I'm going to see what happens here. Now what I'm doing, I'm actually going one step ahead of my try catch, which is creating a nested try catch. Now this is nothing but a nested try catch within my main try. What I'm doing, I'm actually trying to catch this exception. Now what is the use of this? The use of this is, now whenever I run the program, if any exception happens here, if you remember, this is like a filter. If any exception happens, it will catch here and that's it. It will suppress the exception till here and then it will move to the next statement. That is the main advantage of actually handling the exception, right? Now you can see any exception happened previously here, but it actually went to this read key, right? And until unless we gave a read, input, it was not closed. Same way, I'm actually going to my nested. Now here you can see I'm getting some error here. It says it does not, I doesn't have a context for this. Why? Now if you remember our scope, now whenever we define any variable or any object variable, right, inside my block, it can be try or for loop or a if loop or a while loop or a do while, anywhere, right? The scope of that variable becomes only within that. But what I'm doing, I'm using this I outside the scope. That's why I'm getting error. So what I do, I just declare this outside here and I'm gonna use it. Right? Now this is a simple way of it. Now what I'm going to do here is I'm going to use the same here. I'll just say nested exception occurred and I'm going to take it as exception. Right? Some other message I'll produce. Now see what happens. So now here we have moved a step ahead and created a nested exception for one line, which is my I is equal to so and so, where I am predicting it may go wrong in future. Now let's run this. So let's debug this. So here what I am going to do, now this is a situation where I don't have any error, right? So see here what happens, my I becomes 0 and here what I am going to do, I am going to take the value. Now as I don't have any error, now you can see it will skip this catch. Why? Because there is no error. Now if you go to X, it will calculate my X and it will fit. And here my main try is done and it won't go to catch, rather it will go to family and then now this is how you have it. Now let's create an exception. See how it works. Now here you can see I may get error because my size of array may go out of range. When I run this, see, immediately it will go to the immediate exception catch. Because whenever I start my try block, right, again internally or nestedly it will actually start the tracking of exception, and if any exception happens, it will throw exception to immediate cache, and that's it. Now this will suppress your exception. Now see what happens. It will actually print the error, and that's it. Now you can see it will move as if it actually goes to the next statement. Now it is different that we are getting this exception, right? Again here, why we are getting exception? Now here you can see my I value is 0, right? Now you can see what exception happened. Now you can see that I had two different exceptions. One here I had an option to do, and you can see that one more exception happened here. Why? Because I assigned I value as 0, and what I'm trying to do? I'm trying to divide a value with 0. That's why I've assigned 0 here, if you remember. Now this is one more type we have got. Now if I run this, now you can see there are two different exceptions I got. Next exception that index was out of bounds, and internally you can see attempted to divide by 0. Right? This is one more time. Now which means what can I do this? Because this is my mandatory operation, let's say, right? Then what I can do? I can write something called if any exception happens, what I can do here, I can assign it with 1. Let's say. At least I have to take 1. Now that's what we do with catch. If any exception happens, you have to handle that exception and make sure you are, by default, you are setting some values to so-and-so. Then let's see what happens now. Let's say here I have an exception. What I am doing, I am actually initializing my I with 1. Now what happens? My I becomes 12. Now it's completely perfect, and I am coming out, and it will come to finally, and that's it. Now you can see everything went fine, even if I have an exception here. This is correct. Now let's take one more situation. Let's say I am actually having 0 here, which means I am trying to get a value at 0 position. What is the value at 0 position? It is 0 again, which means there is no exception here. Let's try to run this. Right? There is no exception here, but what is the value of I? I value is 0. See here what happens again? Exception happens here. So what to do again? Right? Okay, and I know that I can't use this line. Right? I can use, what I can do, I can actually use this line here. I can do that. But what happens if any exception happens here? Then again it distills. For that reason, what you can do, you can create any number of nested try catches. That's a catch here. I can create one more nested and I can do this. Right? Which means if any exception happens again here, what I'll do, let me just build here nested, second nested maybe. And what I'm going to do, at least if any exception happens, say let me call it as T or TX something. If any exception happens here at least, then I'm going to make it my X value as at least 2. Which means if any exception happens or whatever happens, it doesn't matter. At least my X value will be printed with some value. Let me take this out because you can see X scope is only to try and catch. I'm going to use this here, right? So let me just declare this X here. And you can use. Fine. Now let me debug this. See here we have, right, everything went fine. And here you have X is equal to 0. Now here you can see I was 0, that's why exception happened. Now you can see it immediately will go to the nested catch, to this catch. And what I am doing, I'm printing that I'm assigning my X value to 20, which means my remaining things will work fine. Now it will it will close the main try and immediately come to finally, and that's it. Now you can see nested second exception happened, which is attempted to divide by 0, but my execution completed. Right? Now this is how we can handle exception and the internal or nested try catches, how we can handle, right? And also the nested, if there is any exception in cache, what we are doing, we are actually doing some initialization to that. So this is how we normally handle exception. And for the nested try catches, yes, you can also have finally. Now this finally will be executed specific to this, right? Let's say here I'm going to copy this and I'll say this is first nested finally block, right? And I'm gonna take finally here also. I'm going to call this as second second nested finally. Right? You can have finally any number of finallys, but finally should be attached with one try. Right? Anyways, we are actually checking out one try. We'll see multiple combinations again. Right? So when I run this, now you can see I have my execution going on. I came to my first nested try one. There was no error, but it went to finally. You can see finally is a mandatory block or a short block which will be executed for that try. Right? Again, you can see an exception happened here, and I'm doing so and so, but it will come to finally. And my repeat. You can see finally you have first nested finally, second nested finally, right? And my execution is completed and your finally block got executed. Right? So this is how we handle exceptions. From now on, whatever program you're writing, make sure you're actually handling. So this is the best example, like I think Sundar or Prati, I think you guys have written program where you just enter space, right? If you remember in your calculator program, while accepting numbers, during accepting your read key or read line itself, you try to pass it to integer, and you by chance you entered space. Then what happened? Obviously, space is something which is not a numeric value, and you are forcefully trying to convert it to it. Now that is where your exception handling will work, right? Because it is not intended, but somehow you actually entered some character which is not a number. Right. So this is about exception handling, how we use nested. We have more things to see in exception handling, right? So we'll check out in next class what exactly are there.